Show that in parallelogram ABCD, where A vector and B vector denote the two adjacent sides, AB vector and BC vector, the length of its diagonals, AC vector and DB vector, are represented by A vector plus B vector and A vector minus B vector, respectively. Let us begin. So first what we'll do, we'll start with the proof here. So here, let us consider a parallelogram with vertices A, B, C, and D. Now in this parallelogram, it is given here that AB vector, or we can say the side AB of the parallelogram is going to be a vector, and it is given that this is equivalent to the vector A. So AB is nothing but vector A. Then this is going from A towards B. And then we have BC vector. So BC vector means a vector going from B to C, and it's given here the BC vector is represented by the vector B. So using this information, we need to show that the diagonals AC of this parallelogram is given by A vector plus B vector, and the other diagonal by joining D and B is given by A vector minus B vector. Let us begin by first joining the vertex A and C. So here we have joined vertex A and B, and we are going to represent it by a vector going from A towards C, so that we can apply the triangle law of vector addition. So we're going to consider the triangle ABC. So here from the triangle law of vector addition, so when we add AB vector with BC vector, so that's going to give us AC vector. That means we have A vector added to V vector, and this is nothing but AC vector. So we have successfully showed that the diagonal AC of the parallelogram is given by A vector plus B vector. Okay, so this is done. Now what we'll do, we will join D and B. Now we join D and B and represent it by a vector going from the vertex D towards B. Now let us consider in triangle DCB. So what we'll do, we'll consider the vector DC vector. So we have DC vector, we're going to add it to CB vector, and this is going to, the sum is going to give us the third side, which is DB. Now here we will be representing it by a vector DB. Fine. Now what is DC vector here? Now since ABCD is a parallelogram, so DC vector will be equals to AB vector. So this will be exactly the same as AB vector. However, we are going from C to B. In the previous case, we consider going from B to C, which is represented by B vector. So let's do one thing. Let's take its opposite direction. So here we'll have negative BC vector. In other words, we're saying the CB vector is equals to the negative of BC vector, and this will be equals to DB vector. So what is AB vector? So AB vector, so that's A vector. Then we have minus BC vector. So BC vector is B vector. So this will be equals to DB vector. So hence we have successfully showed that the other diagonal DB of the parallelogram ABCD can be represented by the vector A vector minus B vector. Hence, we have showed both the two parts.